Good day, everyone. Welcome once again to our lecture for today. So today we are going to continue our topic on the limits of a function. Okay, so this is the example that we had solved yesterday or last time. So today we are going to have another properties that is based on what we have discussed so far in our previous lecture. So based on our discussion in the last uh, lecture, so I hope you have noticed that if domain or if a is in the domain of the function, so the limit of function as x approaches to a or approaches a is simply f of a. So we say that the limit can be evaluated by simply direct substitution. Alright? So because of this, it leads us to the following theorems. So first theorem here, if p is a polynomial function and a is any real number, then we have p sub x as x approaches to a is equal to p sub a. So we simply substitute the value for uh, x. So in this case, we have x approaches to a, so we change here x to a, and that would be our answer. Okay, so that is first theorem. The other theorem is if a is a rational function and if a is a real number such that a is in the domain of f, then we have the limit of f of x as x approaches to a is equal to f sub a. So it means, class, you just substitute the values of x. Okay, to evaluate the limit of that function, you simply substitute the value of x, so in this case. Okay, now to determine the limit of a rational function as x approaches a number which is not in the domain of the function, so we either it's either the limit does not exist, or we use a replacement theorem to show that the limit exists. So because there are times, class, that when you substitute the value of x to the function of x, so we cannot find the limit, or the limit does not exist. So if that case happens, then we have another theorem. We call it the replacement theorem. So to see if the limit really exists, so we have what we call replacement theorem. Because there are times that even if the limit exists, but when you substitute the value of x to the function, it makes the function or the expression does not exist. So we have to use the replacement theorem. So what is this replacement theorem? So this is the theorem, class. Let a be a real number, and for all f of x equal to g sub x, for all x not equal to a. So if the limit of g sub x exists as x approaches a, then the limit of f of x also exists. And we have this theorem that the limit of f of x as x approaches to a is simply equal to limit of g sub x as x approaches to a. So what does it mean? There are times, class, that the function is given in a very complex form, but if you can transform it into something using, like, for example, factoring, or say multiplication of its how do you call that, or multiplication of its conjugate, and you can transform the given function, then there's a possibility that if you can do that, then you could tell that the limit exists. Okay, so we have to use this replacement theorem. Alright, so let a be a real number, and for all f of x equal to g sub x, for all x not equal to a, so if the limit of g sub x exists as x approaches a, then the limit of f of x also exists. And we have this theorem that the limit of a function of x as x approaches to a is equal to the limit of another function of x as x approaches to a. So in other words, class, the f of x here is the more complex representation of the function, and then after applying the concept of factoring or multiplication of its conjugate, then you transform this function into another function, we call it g sub x. Now if you substitute the value of x as x approaches to a, if you substitute the value a to x, and if the limit of this g sub x exists, then we can also say that the limit of f of x is also exist. Alright? So for example, if you're given this limit of a function, we are asked to evaluate this expression, limit of f of x as x approaches to 5, if f of x is given as a rational function, x squared minus 2x minus 15 divided by x minus 5. Now if we are going to apply the concept that we had learned previously, like for example substituting the values of x equal to 5 to the given function, so we see that if this is 5, so 5 minus 5 0, so that makes the function undefined, right? If you substitute the value of x, the denominator becomes 0. Now if you are going to substitute also x equal to 5 to x at the numerator, what will happen? So this is 5 squared, so 25, minus 2 times 5 is 10, so 15. 15 minus 15, so this makes 0. The numerator is 0, the denominator also 0. So that means that it doesn't exist. No? But if you have 0 at the numerator, 0 at the denominator, it just tell us that there's a possibility that there's a common factor between the denominator and numerator. Okay, so now let's evaluate this. First, let's see if we can use the replacement theorem. Okay, so replacement theorem, what does it says? That f of x f of x equal to g sub x. If f of x equal to g sub x for a value of a not equal to or a certain value, if this one exists, if the limit of this exists, then the limit of this also exists. So the answer here is that by direct substitution, we can see that it fails. No? It will give us 0 divided by 0. So direct substitution fails to give the limit since the expression is not defined when x equal to 5, right? So if you have denominator 0, numerator 0, even if only the denominator is 0, so that makes the expression undefined. Okay, so next we need to do something. No? We have to apply factoring. So this 0 over 0 plus, so this 0 divided by 0, it tells us something. No? However, the limits of both numerator and denominator is 0. So which implies that they have a common factor given by x minus 5. Okay, x minus 5. So if you look at the numerator, so you have x squared. So the numerator is x squared minus 2x. minus 15. So can we factor this numerator? So what are the factors? So x squared has the factor x and x, right? So the factors for x squared is x and x. Then the third term, the factors are, so 15, meaning the factors are 3 and 5. And you look at also the middle term, negative. And this is negative, so your factor must be plus and minus. So since the middle is negative, so we can say that the bigger factor must be negative. So this would be 5, minus 5, and positive 3. So therefore, the factors are, we have x minus 5, okay, and x plus 2. Alright, so these are the factors at the numerator. Okay, so x minus 5, so the first factor, then x plus 3, second, sorry, this is 3. Sorry, because this is 3. Okay, so x plus 3, so these are the factors. So therefore, so we can write f of x equal to x squared minus 2x minus 15 divided by x minus 5 as x minus 5 quantity x minus 5 times quantity x plus 3 divided by x minus 5. So you have x minus 5 at the numerator, you have x minus 5 at the denominator. So what is left is we have x plus 3. No? So this is x plus 3. Okay, so in our replacement theorem, this x plus 3 here, which is equivalent to this ratio or this rational fraction, so this is what we call the g sub x. Alright, so this is our g sub x. This is the result after we evaluate this fraction. Okay, so we apply factoring here, and we have a common factor at the numerator and denominator. So what is left? So x minus 5 divided by x minus 5 is 1. 1 times x plus 3, we have x plus 3. So this is our g sub x. So which is equivalent to function g sub x equal to x plus 3. So take note that the condition x not equal to 5. Now from this, the condition is x should not be equal to 5. Otherwise, this makes undefined. But actually, the limit exists. So we say that if we substitute the value of x here to this new function, x which is equal to 5, so this becomes x plus 3 or 5 plus 3 equal to 8. So it exists. So the g sub x, the limit of g sub x exists. So therefore, the limit also of f of x exists. So we just replace this by this one. Okay, so limit of f of x as x approaches to 5 equal to the limit of g sub x as x approaches to 5, which is equivalent to limit of x plus 3 or limit of the quantity x plus 3 as x approaches to 5 equal to, applying the previous theorem, we have you change x to 5, so 5 plus 3 equal to 8. So therefore, the limit of this function f of x equal to x squared minus 2x minus 15 divided by 5 is equal to 8, and it exists. Alright? Okay, so that's it. So that's how we evaluate limits if the given expression cannot be or the given limit expression cannot be solved by direct substitution. We have to do something applying the factoring in that example. And there are some examples, some cases that you need to apply your skills on uh, about the conjugate. No? Multiply both numerator and denominator by the conjugate. So that is if you're given the rational function. Okay? Now another example, evaluate the following limits. So we are given limit of x squared minus 2x minus 8 divided by x squared minus 16 as x approaches to 4. Alright, so by direct substitution, what will happen? If, for example, you do the direct substitution, of course, you have to start by seeing the method of direct substitution if it will work. So in this case, if you substitute x equal to 4 to the x's here, so what will happen at the denominator? So this becomes 4 squared, so 4 squared minus 16. 4 squared is 16, 16 minus 16, this makes 0. Then if you substitute here, so this is 16, 4 squared 16 minus 2 times 4, that is 8. So 2 times 4, 8, so negative 8, so minus 16. So 16 minus 16, so this also makes or give us 0, 0. So again, if you have this 0, 0, so that indicates that there would be a common factor of both numerator and denominator. So how are you going to solve it? So we cannot use the direct substitution because it gives us 0 divided by 0. So that makes the limit undefined, or we cannot determine the limit. Okay, so to do that, we'll apply. So what shall we do? We are going to apply our skills in your algebra. So what are the factors, class? Okay, so first we have to factor the denominator. Okay, so what are the factors of the denominator? We have the factors here are x minus 4 and x plus 4. So take note, class, that this is already algebra. So we need our skills in algebra here. Okay, so these are the factors of the denominator. By the way, we have to write the limit first. So in your solution, okay, so this is equal to, so write first the limit. So don't forget to write it this way. So limit, when you're doing your solution, so limit of the new factor. So the denominator, we have the factors at the denominator is x minus 4 and x plus 4. Okay, at the numerator, the factors are, so what are the factors of x squared minus 2x minus 8? So the factors are, we have x, so this gives us hint, one of the factors at the numerator is the same as one of the factors in the denominator. Okay, so you have 8, the factors of 8, 2 and 4, right? And then since the middle term is, by the way, 8 is negative, so therefore the factors here are plus and minus, negative, positive. Since the middle is negative, so we take the bigger value or bigger factor as negative. So in this case, we have negative 4 and positive 2. The factors have 8. So therefore, we have, okay, so parang clear. So we have x squared minus 2x then minus 8. Okay, so factors for x squared. So we have x and x. Okay, and then the factors for negative 8. So as mentioned, 4 and 2, right? And since this is negative, so by the way, negative tong 8, so we have negative and positive factors. Since this is negative, I'll take the bigger value as, the 4 as negative and the 2 as positive. So now the factors are, you just do this one, x and this minus 4 here. So you have x minus 4. Okay. And then you have another x here. So another x here. Okay. So you have x and another factor here of 8. Negative 8 is positive 2. So x no sign, so it means that's positive. So x plus 2. And you see that both numerator and denominator have the same factor. We have x at x minus 4 at the numerator. We also have x minus 4 at the denominator. So x minus 4 divided by x minus 4, this is just equivalent to 1. Okay, so what is left? So what is left is simply, so again, don't forget to, by the way, this is as x approaches to 4. Don't forget to write it in your solution. I want to see it as x approaches to 4. So again, you are not yet finished here, so you have to write again the limit. So limit. So what is left in the numerator? We have x plus 2. Okay, and then at the, by the way, this is, you have to write, you have to enclose this with a quantity. Okay, so x plus 2 divided by x plus 4. Okay, so enclose this also with a parenthesis as x approaches to 4. Alright, so now if you look at the expression, the limit expression, you can do the direct substitution. Now as x approaches to 4, so you can substitute. You have 4. Okay, so 4 then plus 2 divided by 4 plus 4, or this is 6. Okay, this is 6 over 8, or what is 6 over 8? So 6 over 8 is equal to, so divisible by 2. So 6 divided by 2, this is 3. 8 divided by 2 is 4. Okay, so we have the answer equal to 3/4. Okay. Now how about the second number? Okay, so for the second number, what shall we do here? So it involves radical. Okay, so for this case, we can, okay, I will, let's solve it here. So for number 2, we have limit. Okay, so I'll just go directly to equal. So for this number, I'll start it here. So this is equal to, so limit of square root of 3, oh sorry, square root of x minus 3 divided by x minus 9. So quantity, then as x approaches to 9. So now if you do the direct substitution, what will happen? Okay, so if x approaches to 9, so 9 minus 9, this makes 0. Okay, so 9 here, square root of 9, 3, minus 3, 0. So you have again 0 divided by 0. So to solve this, the technique is to multiply it by the conjugate. Okay, since you have a radical here. So what does it mean, conjugate? So if you are given a radical, then the second term is negative. So the conjugate is radical plus the conjugate of minus is plus. So you have to multiply this by, okay, you have square root of x, then plus, okay, so plus 3. So square root of x plus 3 is the conjugate of square root of x minus 3. So what we do, or what we did in the numerator, we have to do also in the denominator. So what is the purpose? So the purpose is to help us solve this problem. Okay, and take note that we are not changing anything, right? We are not changing the limit function here. So because square root of x plus 3 divided by square root of x plus 3, that is just equivalent to 1, right? So 1 multiplied by this limit function, so the same, nothing happens. So we just manipulate it in a way that it will lead us to the solution to this problem. Okay, so again, you write this limit. So this is a very tedious process, class, because you need to write it. So you just do the substitution after you transform or get the replacement of the given function. So as x approaches to 9. Okay, so we have here the quantity. So when you multiply, this multiplication class, the numerator multiply, the rule in multiplication of fraction is that you have to multiply the numerator and multiply the denominator. So we have here the numerator or the numerators, so we have to multiply them, and we also have to multiply the denominators. So to multiply, we have two terms here. We have a binomial multiplied by another binomial. So square root of x times square root of x, that is equal to simply x, because square root of, if you have square root of x times square root of x, so this is the same as, square root of, you can put them together in one square root or in one radical symbol. So square root of x times x, right? So we know that from the law of exponent, you have the same base. Ang exponent nila is both 1, 1, 1. So x squared, x times x, so it's just the same as x. Then you just multiply, you just add the exponent of the 2, which is understood to be 1. So 1 plus 1, we have 2. Okay, and then square root. So we know that square root and the index here is 2, and this is the same as power of 1/2. So it means that you have x squared. This is the same as x squared. The square root there, it means that you have to raise the power 1/2. Okay, so x squared raised to the power 1/2, so this is simply x. So that's why we have x here, x. Then we have square root of x times positive 3, so we have plus 3 times square root of x. Okay, so we're done with the first term, multiplied both the first and second term, the second binomial. So next we have the second term, which is negative 3. So negative 3 multiplied by square root of x. So what we did first was first term here, multiply natin every term of the second binomial. Next is you have the second term, we'll multiply this with each of the term the second binomial. So negative 3 times square root of x is square root of x, 3 times square root of x. Then we have 3, negative 3 times positive 3, this is negative 9. Okay, so that's our numerator. Then for the denominator, okay, we just copy them. So x minus 9, okay, x minus 9, then multiplied by square root of x plus 3. Okay, so if you look at the numerator class, we can see that we have here positive 3 square root of x combined with negative 3 square root of x. So it means these two become 0, because positive 3 square root of x minus 3 square root of x, that's become 0. Okay, so that makes our numerator to be x. So what is left in the numerator is x minus 9, right? Okay, so this is what is left in the numerator. The denominator, so again you write this limit, okay, limit as x approaches to 9. Okay, so x minus 1, then the denominator you have x minus 9, then multiplied by square root of x by x plus 3. Okay, so whole quantity, something like this. And what you've noticed is that at the numerator we have x minus 9, and denominator we also have x minus 9, so x minus 9 divided by x minus 9, that is 1. So what is left in the numerator is only 1, right? So we have 1 at the numerator. At the denominator, what is left is square root of x plus 3. Okay, so this is square root of x plus 3. Then this is under the quantity or inside the quantity, so limit of that function as x approaches to 9. So now if you look at the remaining or the resulting expression, you can see that if you substitute x equal to 9 to the expression, this gives us a limit already, right? So therefore you can now substitute. So this is now equal to 1 over, now when you are substituting class, you don't need to write this anymore, okay, because you are now substituting. So square root of 9, okay, then plus 3. So what is square root of 9? Square root of 9 is simply 3, so 1 divided by 3 plus 3, or equal to 1 over 9. Okay, so that's the solution for the second example. Any question? Oh, sorry class, this is not 1 over 9, because this, we're not multiplying here. This is 6. So this should be 6, because 3 plus 3, right? Square root of 9 is 3 plus 3 is equal to 6. Sorry for that. Okay, so this is 1 over 6. Okay. How about this number? Alright, so for the the third and the fourth number, I think this is manageable already. But let's see, let's try number 3. I'll give you number 4 as your practice. Okay, so for this one, for number 3, so I'll write it here. Okay, so this is for this number. Okay, so this is limit so what we do here, we have two ways of doing it here. So we can either multiply it by the conjugate, or you just expand this. Okay, so expanding the numerator. So how to expand the numerator? You have, I don't know if you can still remember this from algebra. If you have u plus v, squared. Okay, this is equivalent to binomial expansion. You have u squared. So it means square of the first term. Then our second term is, so this is plus, so this is also plus. The second term is just twice the product of u and v. First and second term, so 2 times uv. Okay, then plus square the second term. Our second term is v, so you square that one, that is squared. So let's try if you can do this. So our first term here is x, so we have x squared. X squared, then plus our second term product, not twice the product of the first and second term. So product of the first and second term is x times 2, or 2x. That's the product multiplied by 2. So this would be 4x. Alright. And the third term is square of the second term. Our second term here is 2. You square that one. 2 squared is 4. Alright. And then we have minus 4. This minus 4 here. So minus 4. Okay. And then the denominator is x. Okay, so because we cannot substitute when x approaches to 0, what will happen if you do the direct substitution? That will make the expression undefined. Okay, so that's why we try to do something at the numerator. Alright, now so if you combine similar terms, so we have here positive 4 and negative 4. So it means when you combine this, positive 4 minus 4 is 0. So what is left? Okay, so what is left in the numerator is just x squared plus 4x. Okay, this is what is left in the numerator. And the denominator is still x. Okay, again, you write it this way. So we have limit of the function as x approaches to 0. Now, if you look at the numerator class, we can see that there's a common factor. So, common factor of the numerator is x. So, factoring out x. Okay, so what is left in the first term? That is only x. Second term is only 4. Okay, and we have the same denominator. Okay, this is x. So again, so close this with a parenthesis. Then we have here limit as 0. So limit of the function as x approaches to 0. Okay, so you see that at the numerator we have x, and denominator we have also x, so common factor. So we can say x divided by x is equal to 1. So what is left in the numerator and in the denominator, so this becomes the numerator we have x plus 4. Okay, now denominator is only 1, so you don't have because x divided by x is 1, or wala na to. So what is left is x plus 4. Then we have limit. Okay, so limit as x approaches to 0. So this time you can now do the direct substitution or the substitution. So therefore, so when x approaches to 0, so we have 0 plus 4. So the answer is equal to 4. Okay, so this is the limit of the function. It's equal to 4. Any question? So I hope it's clear, and I want you to practice this one, this number 4, and I hope you can use that skill, no, in our quiz number 1 soon. Okay, so there are other exercises here that you need to practice also. So you have given these numbers, and please try to solve them as well, and be ready for our coming quiz number 1. So the previous activity, graded activity, that was your assignment number 1. Alright, so next time we have quiz number 1. That includes already the limits of functions. Of course, you also have to study again the function, because I will take also some of the questions from that topic, functions. Alright, so that's all for today. So just practice these few numbers here for your exercises, and be ready for our quiz number 1. Thank you very much, and have a good day, everyone, and stay safe and healthy always. God bless, and bye-bye for now.